What we did last time was, this is the condensing stuff. It's undoing all those log rules, like the power rule and the quotient rule. I start with putting the exponent back. So just to recap last time, so see that 5 out front of log and that 2 out front of the logs? I put it back. You put it back in there. So then, if you do it to all of these, if you ever see like this 3 out front here, get it up there. Get it out of the way. Get rid of your log coefficients. Get them out into the exponent position. That's condensing. That's putting things toward getting to 1 log. Condensing, your goal is to get to 1 log. Expanding, you want to get out to is applying as many of those rules as possible. So this is 3/4. And I'm going back to something, I think, did we do these, by the way? We got this far? Okay. So I'm assuming this is out there. The only thing about this next piece, division, the subtraction, this is what the gatekeeper just told us. She said that we could take the quotient of those, since it's subtraction of the same base log. Subtraction again happens, so I could do that on the next one as well. Okay, it's not showing anymore because it got stuck. So let's see if I can get my screen to show anything. Well, it's happening for me. I don't know if it's happening up there for you guys. Weird. Yeah, it's not writing what I have on my screen. Whatever's going on there. Okay, so the next part is whenever it came, good, it showed up. The next part is if you have any log in pairs, like adding, you want to put those as a product. And we did all this in class, and you do it in steps, and it can be beautiful. You can get it all down to this single log. After you get to a single log, the rest is basic algebra, like simplifying. The condensing using log rules is use those to get to a singular log. Each case, I've got all those as a singular log. You might want to simplify a little bit, just depending on what your needs are for the problem. So x to the 5th over x squared makes x to the 3rd, things like that. So just keep that all in mind. I can't do anything with number 8. That's good to go. On the last one there, I could probably take all these negative exponents and put them into a better position, make them in the denominator. Optional. That's all. The condensing is using the log rules to make a single log. Now, the change of base, 10, 11, and 12, that's the new stuff. We did not do change of base. We were aces of bases minus this technique. You're going to need a calculator. I'm going to show you something. Now, my calculator does some cool stuff. So I'll pause this recording, and I'll show you my calculator here in a minute. So you can rewrite any log of any base as the log of the number inside the number inside the log. Take the log of that over the log of the actual base, which in this case is 3. I know it's tiny. Can you see that's a 3 right there? But log of 16 over log of 3, I can rewrite that. Now, I use natural log. It doesn't matter what kind you use. I could use log log. But to do logs of different bases, you actually take the log of log log or ln log, the two that your calculator can actually do without much manipulation. And you divide the log of the number divided by the log of the base. Now, it actually ends up being the same-o, same-o. So I'm going to pause. So the long and the short of it is, if you want to get the value of a log with a different base, you just take natural log of the number in the base in a quotient, or log of the number in the base in a quotient. You'll get the same result. It just depends on what button you want to use. Pretty weird, huh? Pretty weird. So, and if we had ever had time in this world, that'd be a fun one to prove, why it's equal, why it works. Even log base 1/2 of 2, natural log of 2 over natural log of 1/2. You got it, and it's done. Isn't that cool? Let's graph. Graphage. It is time to graph. So if I'm going to graph this, okay, here's how I get log base 5 of x. I put it all up there at once so you can kind of see it in action. This is log, I forgot to say you're here. Yes, the gatekeeper is here. Does she know who that? Hi, Ellen. Taylor is here. Taylor Gates. You bet. Bye-bye. I almost said gatekeeper. So close. Okay, so this one right here, 440. This is 1, 0. That's your regular log. Do you know the basics of logs? Have I ever shown you guys this? Have I ever shown you this? Probably not. Let's talk about logs. That's the graph of a log. Not recently. you have to know the graph of a log of any base x. The key features are it has a vertical asymptote at x equals 0, and it goes through 1, 0. It can be log base e, natural log. Log base 10. They all go through 1, 0, and they all have a vertical asymptote of x equals 0. Now, using that crazy knowledge, just go back. Let's get there. Yeah, we want to go back a little bit further. Right over here. Now we have this graph. All I do is graph that basic log base bx, whatever it is, kind of make it look like that and call it good. Now down below, here's what I put on here. The screen I don't show you necessarily here. That little drawing right there, this is 5 to the x. I wanted you to see the comparison of the inverse function. So this is log base 5 to the x, log, and then just 5 to the x. They're reflections over the y equals x line. They're inverses of each other. So you can kind of get a sense they're perfect mirror images over top of that. So all the properties that you see in 5 to the x, like going through 0, 1, after inversion, it goes through 1, 0. This kind of has a horizontal asymptote of 0, and it goes up. This has a vertical asymptote of 0, and it heads along the x-axis instead of the y-axis. So nice little, I think I just said lice. It's a nice inversion, properties that are inverted. And it's recorded for posterity. I just said lice. That's so crazy. Try another one. So here's 1/4 to the x. Oh, forgot that part. Okay, there's 1/4 to the x. Before I graph log base 1/4 to the x, I'm using the same idea that I know what 1/4 to the x is. It's a decay function because it's between 0 and 1, the base is. If I invert that over the y equals x line, I can get a picture of log base 1/4 of x. Want to see it? Are you picturing it? Just imagine it in your mind. Flippity flip. Ooh, is that what you pictured? Look at that. Mirror image across the y equals x line. Crosses through the point 1, 0, just like the other one went through 0, 1. The nice inverse properties that go with it. Okay. I want to show you in general kind of what these graphs look like, so I'm going to pause this one again. Recording. So if I graph these now, I can work a little faster with my ninja writing. So there's b to the x, there's log base b to the x. I just kind of drew a basic graph down there. Now, log of x, now that I know the general graph of it, here's the deal. Check it out. If I know what a log graph looks like in general, well then heck, I can move it right to an up 1, no problem. Just take that, that 1, 0 point. You move it right to up 1. There's your new 1, 0 point. Remember that x equals 0 vertical asymptote? Well, you just move it over to. Because everything got shifted right to. Now you can move a vertical asymptote up, but that's not going to do a darn thing. Not at all. But that's the process of shifting the log graph right to up 1. The things that you have to know about a log graph are where it hits the x-axis and where that vertical asymptote is. The rest, no problem. Okay? What do you think? That okay so far? What about, hey, let's move it left 1. Just take that vertical asymptote over one spot. Instead of going through 1, 0, it goes through 0, 1, or 0, 0. So it's not over 1, up and 0, it's just 0, 0. Just knowing the basic log graph, you can move that singular point and the vertical asymptote around and you're golden. Making it look steeper and stuff, that's too hard. I won't make you do that. We have calculators that'll help with that later. All right, onward and upward. Don't forget, there's your log graph. Know it and love it. It's pretty. Okay. You guys are ready for the next big thing. I think we should take a quiz. Don't you think?